In this video, we're going to prove that 1 plus the sine of negative x divided by 1 plus the cosecant of negative x is equal to negative sine x. So we're verifying or proving a trig identity, and so what we want to do is we want to pick out the more complicated looking side to start out with. If we want to use different algebra techniques or any of our trig identities that you see on the right hand side to try to make it look like or to transform it into the other side of the equal sign. So in this case, we want to make the left hand side look like negative sine x. So the first thing that I notice when I'm looking at this problem is notice on the left-hand side we have sine of negative x and cosecant of negative x, whereas on the right-hand side we just have negative sine of x. And so what that tells me is there's something that we need to do to get those negatives out so that we just have sine x and potentially cosecant x. So that's the first thing that I'm going to tackle when I look at this problem is I'm going to take advantage of the fact that sine and cosecant are odd functions. And being an odd function basically just means, especially when we're talking about this trig stuff, this is very convenient, it means that you can just pull the negative outside. And so what that means with cosecant and sine, and tangent is also this way, since they're odd, it means that sine negative x is the same thing as negative sine x. And also cosecant negative x is the same thing as negative cosecant x. And so those are two other identities that you see I don't have them written on the right hand side, and they're essentially the even and odd identities, and there's a whole list of these other ones, and they're all listed off where the odd ones you can always pull the negative out. The even ones, like for instance for cosine and secant, basically the negative can just go away and it's going to equal the same thing. So you can look over those. They're not used very often, but we do need them for this problem. And so just rewriting the left hand side using these even and odd identities, we're going to have 1 plus sine x. But that negative needs to come out, so that plus is going to turn into a minus. And the exact same thing is going to happen in the denominator. We're going to have 1 instead of plus, the minus is going to come out, and we're going to have cosecant x. And remember, the left-hand side is the side that we're working on. So that's our first step. Now the argument is at least matching on the left and the right-hand side. But there's still a lot of work to do. And the first thing that we need to do is we need to multiply the top and the bottom of what we have written now by the conjugate of the denominator. And the reason for that is, if you look at what we're trying to match negative sine x. And right now we have 1 minus something in the top and 1 minus something in the bottom. So we have to somehow cancel that out. So we're going to multiply, like I said, top and bottom by 1 plus cosecant x. And the reason we're doing 1 plus is because that is the conjugate, and it's going to cause the denominator cancel out, leaving just one term in the denominator. So multiply the same thing on top and bottom. And this is a common thing that you have to do. Unfortunately, it's not very fun, but it is something you have to do from time to time when you're verifying or proving trig identities. And so now we need to FOIL on top and bottom. And so foiling on the top, we're going to have 1 multiplied by 1. That's just going to give us 1. And then we're going to have 1 multiplied by cosecant and 1 multiplied by minus sine x. So we'll have positive cosecant x and minus sine x. And then also in the numerator, the final thing we need to multiply to FOIL it out completely is going to be negative sine x times cosecant x. But notice that sine x is the same thing as 1 over cosecant, or cosecant is the same thing as 1 over sine, using this reciprocal identity right here. And so really when these two things multiply each other out, it really is just going to give us a negative 1, because the sine x and the cosecant x are going to cancel each other out. So we have a minus 1 right there. And so now foiling in the denominator, we're going to have again 1 times 1, 1 times cosecant, and 1 times negative cosecant. So all we have left over there is a 1, because the cosecant positive and negative are going to cancel each other out. And then the final thing we'll have, let me get that in blue, is going to be negative cosecant times cosecant x, and that's going to give us negative cosecant squared x. And so we did a lot there. We just FOILed out by multiplying the top and bottom by the conjugate of the denominator. And now some things are going to continue canceling away. We're going to have positive 1 and negative 1 in the top, so they're going to destroy each other. And so what we have left is cosecant x minus sine x over 1 minus cosecant squared x. Now, if you look for cosecant squared x, we can change that into 1 over sine squared x, again, using our reciprocal identity that I starred in red. We can also do the same thing in the numerator with the cosecant x. And this is just a stage where if you don't see anything else to do, a good thing to do is to just turn everything into sines and cosines, and hopefully everything will work out. So changing the cosecant x in the numerator to 1 over sine x minus the sine x that was already there. And the denominator will have 1 minus 1 over sine squared x. And so now a good thing to do in the top and bottom would be to find a common denominator. And so that's exactly what I'm going to do. In the top, we will have a common denominator of sine x because we have 1 over sine x minus sine x over 1. And so that would give us 1 minus sine squared x over sine x. That's just the numerator, common denominator. And then the same thing in the denominator of the overall fraction. We'll have 1 minus 1 over sine squared x. And the common denominator there would be sine squared x. So we'll have sine squared x minus 1 over sine squared x. And I know there's a lot going on right there, but just keep in mind, all we did was find common denominators in the top and the bottom of what we had right here. And now we have a fraction divided by a fraction. So what we're going to do is we're going to multiply the top by the reciprocal of the bottom. So we'll have 1 minus sine squared x over sine x multiplied by sine squared x over 1 minus, or actually sine squared x minus 1. But sine squared x minus 1 is the same thing as negative 1 minus sine squared x. That's just factoring out a negative. So let's go ahead and do that. Let's rewrite it as negative 1 minus sine squared x. And the reason I'm doing that is because now we have everything being multiplied together. We have a 1 minus sine squared, 1 minus sine squared. We have a sine squared on top, which will cancel with one of the signs on bottom. And all we have left over is sine x divided by a negative 1, which is the same thing as negative sine x. And that's it. That's what we wanted to match back here in the beginning. Those two things now match. So we've proven using a lot of algebra and a couple of identities that indeed 1 plus sine of negative x divided by 1 plus cosecant of negative x is equal to negative sine x. And there was a lot we had to do there. This probably represents one of the worst problems you would ever have to do, but I definitely wanted to do one like this just so you could see that sometimes you just have to keep persevering until everything works out.